Everything was changed that morning. And when Cody and I got to the hospital, the first thing the doctors told us, walking in the door, was he was burned 95% of his body, and we don't think he's gonna make it. There's nothing you can say to that.
January 31st, 2011. Two maintenance workers were troubleshooting a problem with a bucket elevator at the Haganese Powdered Metals plant in Gallatin, Tennessee. Suddenly, fine particles of iron dust ignited when workers attempted to restart the elevator's motor. The CSB investigation into that accident was underway when just 2 months later, on March 29th, a similar flash fire burned another Haganese worker. At a news conference in Tennessee on May 11th, the CSB released laboratory test results demonstrating the combustibility of even small amounts of the iron dust when dispersed in air in the presence of an ignition source. Just 16 days after the CSB released those test results, on May 27th, a hydrogen explosion erupted in the plant. The blast shook loose iron dust accumulations from the upper reaches of the building, which ignited and rained down on workers.
Combustible dust is a serious workplace hazard across the country. Since the Chemical Safety Board was established in 1998, 3 of the deadliest accidents we have investigated have been combustible dust explosions. They are entirely preventable, just like the dust fires that occur at Haganese.
The Haganese Corporation is a subsidiary of GKN, a multinational engineering company headquartered in the United Kingdom. The Haganese Gallatin facility, located some 30 miles from Nashville, employs about 180 workers in the production of powdered metals with a capacity of 300,000 tons per year. The main product is over 99% pure iron powder, used primarily in the automotive industry. The manufacturing process releases combustible metal dust into the workplace.
The dust must be controlled and not allowed to accumulate. But when the CSB examined the Haganese facility after each of the 3 accidents, we were alarmed to discover literally tons of accumulated dust on surfaces throughout the facility.
At the Haganese facility, iron powder travels through the plant by a system of conveyors and bucket elevators. The belts on the bucket elevators had a tendency to become misaligned, causing the motors to overload and shut down. On January 31st, 2011, a maintenance mechanic and an electrician were sent to inspect a bucket elevator that had just malfunctioned to see if the belt was off track. It appeared to be aligned properly, and the mechanics radioed the control room operator to restart the motor. The dust collection bag house had been out of service periodically over the previous week. Fine particles of iron dust remained in the area of the motor. As the motor restarted, combustible iron dust was suddenly dispersed into the air. The 2 workers were immersed in a thick dust cloud. Almost immediately, the iron dust found an ignition source, likely an electrical arc from exposed wiring on the motor. A flash fire erupted, engulfing both workers. Both men were severely burned. The first worker died from his injuries just 2 days after the accident. The second survived for nearly 4 months, but died in May of 2011. After the first accident, the CSB documented that combustible iron dust was visible in the air and that it coated most surfaces up to 4 inches deep. These CSB investigation photos show the accumulated dust on elevated surfaces, where the dust could be readily dislodged and ignited. The CSB report noted that engineering controls, such as enclosing conveyors and installing properly designed dust collection equipment, are the best ways to prevent dust accumulations. But as this CSB investigation video shows, the plant's powder handling equipment was not adequately sealed. Combustible dust was always present in the air inside the plant. In this investigation video, dust particles ignite and sparkle as they contact an indoor hydrogen gas flare from one of the plant's furnaces. And employees told CSB investigators that dust collectors were often down for maintenance. Housekeeping measures were the last line of defense for removing the large amounts of dust that constantly accumulated on plant surfaces. But the CSB found that housekeeping at Haganese was ineffective. Those conditions led to a second serious accident at the plant, less than 2 months after the first deadly flash fire. On March 29, 2011, a Haganese engineer attempted to reconnect a gas line to a 20-foot-high furnace following maintenance, but he was having difficulty. Standing on a ladder held by a second worker, he tried hammering the line into place. As the hammer struck, iron dust that had accumulated on the side of the furnace was lofted into the air. The iron dust ignited, burning the engineer, who jumped and fell from the ladder. Partly protected by a heavy flame-resistant coat, he received first and second-degree burns to both of his thighs.
The buildup of so much iron dust near a furnace with open flames and hot surfaces was a recipe for disaster. A fire was basically inevitable the moment the dust was lofted into the air.
Even small amounts of iron dust can produce intense flash fires when ignited, as demonstrated in the CSB's laboratory testing.
If just an ounce of dust can produce such a serious fire, you can imagine the magnitude of the fire and explosion hazard from the estimated tons of dust accumulated at the Haganese plant.
Still, Haganese and its corporate parent GKN did not take effective measures to control the dust hazard. Around 6 a.m. on the morning of May 27, 2011, operators near one of the plant's furnaces heard a hissing noise that they identified as a possible gas leak. They believed that the leak came from piping somewhere below the furnaces. Inside a trench under large steel covers. 6 mechanics were sent to find and repair the leak as another operator stood by. They assumed it was similar to another recent leak that involved nitrogen, an odorless, non-flammable gas. Unknown to the workers, the leak actually involved a different odorless invisible gas, highly flammable hydrogen, used in the plant's massive annealing furnaces. Using a forklift, maintenance personnel removed a trench cover above the area of the suspected leak. As the cover was wrenched upward, metal sparks ignited the hydrogen, causing a powerful explosion. Hydrogen continued to leak from piping, fueling a jet fire. The force of the explosion lofted large quantities of iron dust that had accumulated on rafters and overhead surfaces. Falling clouds of dust ignited as they contacted the flames below. Visibility was reduced by the large quantity of dust in the air. One eyewitness reported that even with a flashlight, he could only see 3 to 4 feet ahead as he tried to escape. 5 workers, including the operator standing by the trench, and 4 of the mechanics were injured, 3 of them with severe burns. 2 of those workers would die from their injuries within days. The 3rd injured worker succumbed 6 weeks later. The CSB noted that on the day of the accident, maintenance crews were allowed to work without testing for dangerous concentrations of flammable gas, and that the facility had no procedures to properly mitigate flammable gas leaks. Haganese did not have an effective mechanical integrity program, allowing corrosion in piping to go unnoticed until the piping failed. And despite mounting evidence of a serious hazard, Haganese did not make major improvements in its dust control program. Haganese tested its powdered metals for combustibility in 2009 and 2010, following warnings from an insurance audit about the potential for a dust explosion at the plant. The company collected and tested 3 powder samples in 2009, all of which had combustible properties similar to the dust later collected and tested by the CSB. Haganese was also aware of the combustibility of iron dust because earlier flash fires had occurred when maintenance workers used welding torches on dust-covered conveyor belts.
When the Haganese facility was built more than 30 years ago, it was not designed according to good practice guidelines on combustible dust, such as those set forth by the National Fire Protection Association, or NFPA. And during its decades of operation, it was never redesigned to address the serious dust hazard.
The Haganese facility has numerous flat overhead surfaces where dust can accumulate, and they are difficult to reach and clean. NFPA 484, the standard for combustible metals, recommends that floors, elevated platforms, and gratings be designed to prevent dust accumulations and to facilitate cleaning. The NFPA standard also requires that all machines that release combustible dust be connected to a dust collection system. The City of Gallatin requires industrial facilities, including Haganese, to comply with the International Fire Code. The code includes a brief chapter on combustible dust. The chapter references the far more detailed dust safety standards of the NFPA, but does not specifically require companies to follow them. As a result, the CSB recommended that the International Code Council revise the International Fire Code to mandate compliance with the combustible dust safety requirements set forth by the NFPA. In its 2006 study on the hazards of combustible dust, the CSB recommended that the Occupational Safety and Health Administration create a combustible dust standard for general industry. In response, OSHA initiated a national emphasis program in 2007 to target industries with combustible dust hazards for additional inspections and enforcement. 2 years later, OSHA announced it would begin rulemaking on a comprehensive standard for general industry.
And I'm announcing today that OSHA will begin the rulemaking on combustible dust.
But in 2011, at the time of the accidents at Haganese, a specific standard had not yet been proposed or completed. As a result, in its final report on the accidents at Haganese, the CSB recommended that OSHA develop and publish a proposed combustible dust standard within 1 year, and ensure that the new standard includes coverage for combustible iron and steel powders. Meantime, until the dust standard is completed, the CSB recommended that facilities like Haganese that handle iron and steel powder should be included in OSHA's National Emphasis Program for combustible dust.
It is a tragedy that 5 lives were lost at the Haganese facility from these accidents. The CSB believes that adhering to recommended industry practices will greatly reduce the potential of a future dust fire or explosion.
Dust fires and explosions continue to claim lives and destroy property in many industries. More must be done to control this hazard. No more lives should be lost from these preventable accidents. Thank you for watching the CSB safety video.
For more information on the CSB's Haganese investigation, please visit csb.gov.